So I now need to get the Arduino controlling the Kali controller. And to do that, I need to remember how to use an Arduino. I last used an Arduino, 10 plus years ago. I don't even know what generation those are. With my friend Andrew's help, I got something called the Seeeduino Nano, which is kind of the same idea. Off camera, I was trying to figure out did I have it working at all? I didn't think it'd be too excited if I had the camera on for an hour while I tried to figure out how to talk to this thing. I'll show you in a second what I've got done so far, where we are, and where I'm going next. So I'm going to experiment with screen recording and trying to put the screen up around here. I hope it works. It's the first time I've done this. So the first thing I had to do was download the Arduino IDE, something developer environment. Anyways, it's the program you use to program the Arduinos. Oh, this was the two 12-volt batteries that had been on the boat. They were quite out of balance. So I charged them back up and I've just been top balancing them. And that was the last set of 4 being top balanced. Because the device I'm using is the Seeeduino, I had to find, in the Arduino IDE, there's like a library of all of the different Arduino type devices that are available. Obviously not being an Arduino, it wasn't default into the library. So I found the JSON file for this, installed it. There's instructions if you buy a Seeeduino on how to do that, and connected it. And I got it working. Actually, I'm not going to connect it just yet. At that point, I knew that I had the IDE able to load programs into the Arduino. They have like a really simple blink program, which you don't do any programming. You just download it and it just blinks the light and you can see that it's working. So once I got that working, the first thing I wanted to try getting working was could I read the data at all from the pot? Normally you'd have that pin that would press down on it to, well, basically set the resistance coming through the potentiometer. A potentiometer is just a variable resistor. Usually it's a dial like you would have seen in stereos and radios and stuff like that. In this one, you have the input here, the output here, and when you press down, it pushes 2 metal plates together, and wherever they press sets the resistance coming out the center pin. And the center pin is being read by the Arduino. I got that working. I'll show a little clip. Got the very basics of the Helm control working now. Let's see, it's dropping to, it should be near 0. There you go. That's about the midpoint. That'll be the dead zone. And then coming all the way up to the other side to get to 1023. You can sort of see, as I move this around, the number drops. Pretty simple. Share it to my Patreons in real time. So once I got that working, I took the 12-bit digital to analog converter, DAC. I did a really crappy job soldering the pins on and a couple of leads on it. I wired it up based on, let's see, I guess I should give credit where it's due. ElectroNoob had a video for this very specific DAC, and its job is to take a signal coming from the software running on the Arduino and translate it into a voltage coming out the other side. I've mentioned before, but I'll mention again, the controller determines the speed of the motor based on a 5-volt signal coming into one of these pins. I haven't figured out which one yet. The 2 ways it can work is you can either have it that 0 volts is no throttle and 5 volts is full throttle, or they have something called, I think it's joystick mode, which is designed specifically for boats. In that situation, when the potentiometer is straight up and down, so center of this, I might have this upside down, I don't know exactly, I have to play with it some more to figure it out. But the point is that when the throttle's like this, it's considered stopped, which it reads there as a 2.4 to 2.6 volt signal. Anything in there and it just shuts the motor off. Less than 2.4 volts goes in reverse. Greater than 2.6 volts goes forward. Now, the resistance, this is a 10 kOhm potentiometer, but that 10 kOhm is from the very top all the way around to the very bottom. If you can imagine this as being a throttle, it's only going to go about 180 degrees sweep. That means that I can't access basically half of this, and that's making me think I might have to reconsider using this. And the reason for that is the resistance that's measured coming in from the potentiometer gets translated into a digital value. 0 being no resistance and 1023 being highest resistance. I might have that backwards, but you get the point. So I have 1024 steps that I can go through. The resistance on a potentiometer is effectively infinite, so it's basically it has to move a certain amount before the Arduino jumps to the next digit. So I lose some of the smoothness and I get a little bit of stepping that happens. If I can only use half of this sweep, that means that I've only really got 512, half of the range to be able to take as an input value. So I'm a little worried at this point that with this potentiometer, the steps between the voltages are going to be too dramatic and I want it to be very smooth. But for now, I will be happy with it just working at all. Knowing now I can only use about 512 steps, say 500 steps just to keep it simple, I'm going to want to go from, say, 250 to 750. At 250, I'm going to consider it full reverse. At 750, full forward. And somewhere in the middle is the dead zone. If I have, say, 240 steps on either side, that means I can take 5 volts, or sorry, I can take 2.4 volts and, well, I guess, Can you tell I'm thinking as I do this? Point is, I have a relatively narrow range, 240 steps to turn into 240 voltages between 2.6 and 5 or 2.4 and 0. Is that going to be smooth enough that I won't notice jittery on the motor? Yeah, I don't know. I'll figure it out. But for now, let's just see if we can get this working. So the first thing I want to do is after I've moved a bunch of stuff around, have I messed anything up here? Is this still going to work? So I'm going to bring up the IDE. I'm going to connect this, open up the serial monitor, which is basically watching the output from the Arduino, and see if pressing this still causes an output here, or if I get the magic smoke. Okay, that's good. Oh, I got a green light on the DAC as well. Ah, okay. In the bottom left of the screen, you're seeing that the numbers are floating all over, and that's because nothing's really pressed here. But if I start here, I'm now at about 242. 300, 400, 500, 600, 700, 800, thereabouts. You can see the number rising and falling as I sweep along the surface. Turn this off. The Arduino itself is super simple. And I'm not a C programmer to save my life. I program in Perl, which anybody who's a programmer probably just had a sad. Anyways, I don't know what I'm doing when it comes to C, and this isn't truly C, but it's C adjacent, and I'm able to make this work. So the very first thing is just the setup. The serial says, take the output and send it to the serial output. So if I had a serial adapter, I could plug this into a computer and collect the data. And this might be how I collect the data coming from the various devices on the boat. I haven't decided yet. That's like 10 steps down. The key thing here is so this is the setup, and then it goes into the loop. Once it goes into the loop, it loops forever until you reset the device or you cut the power to it. So what it does is it reads an integer from the analog pin A0, which is, oh, this is going to be shaky, isn't it? Okay, so that's the ground. That's the plus 5 volts coming out. All of this is powered by the USB off the computer. And this is analog pin 0. So this is a pin designed for reading analog inputs, and that comes to the center pin of the potentiometer. So the value of A0 is read and stored in the sensor value variable. The only thing this program does so far is it then takes that sensor value and prints it to the serial port, which is what we're seeing stream down here. It sleeps for 1/10 of a second and then rescans. So every 1/10 of a second, it's scanning the value here. So in theory, if I moved it fast enough that it was less than 1/10 of a second, it wouldn't see it. But I mean, we're talking about relatively slow throttle inputs here, so that's fine. Okay, so that catches up to where I am so far that I know works. Let me show you what I've done for the DAC, because I still currently don't have any clue how this works. So for the DAC to work, I have to send a signal to this board. So first, this DAC just picks up voltage and ground just to power the board up. And then you send a clock, an SCL, and an SDA. I don't know what SDA stands for yet. I'm watching this guy's video to figure out how this works. So now I've got you up to where I am. I'm going to turn off the camera now, finish watching this video, and when I'm ready to start actually testing this, I'll bring you back. So if I fail and blow it up, you get to see. So I realized one of the things I need to do, let me show you this, is figure out roughly where the sweep's going to be. Obviously this is just experimenting and it's not the real range. I'll be more accurate, but I got to start somewhere. So I'm going to go from full forward to neutral, past the gap, neutral to full reverse. I'm going to pay attention to the values I get basically at the lowest forward speed, fastest forward speed, lowest reverse speed, and fastest reverse speed. And the reason I need to do this is I need to figure out the math. First of all, what are the highest and lowest numbers for the two directions? How many steps do I have between them? And how many volts or fractional volts do I want to jump or drop per step? Let's plug this in, and I'm going to get ready to take some notes with comments. Min forward, max forward, min reverse, max reverse. So min forward, is it not working? Why am I not getting any output? Tell me I've already messed this up. There it is. I don't know why it wasn't coming out. Okay, so min forward, this is not very reliable. I'm starting to think I might be switching to a dial, but this is what I have for now. 115, 190, 115, 110, and I'll say 110, 200. Min forward is 110, max forward is 200. Okay, let's see what min reverse is. Oh, I was touching it. That was probably throwing it off. Yeah, I think I was messing things up. Okay, let me do this over again. Oh, these values are totally different. Oh, go me. So what had happened was I was trying to hold this down, but by holding it down, I was actually pressing somewhere in here, and that's why I was getting weird values. So min forward, max forward is 546, 762. I'm going to round these numbers off. 548, 762. So I'm going to say 550 to 760. 765. Okay, now min reverse is 460 to 258. So if I say 450, come back a little bit. 250 is going to be max. And if I did 115 to keep the steps equal, that would be 365. Was that reasonable? No, that's 460. Oh, it's 200. Oops. So 465 to 250. Does that make sense? 465 to 250. 465 to 250. Okay. So now what I have is the speed variation between minimum forward, maximum reverse, maximum reverse is 215 steps. I'm probably going to make that 220. I've got to do some math, because now what I got to do is I've got 2.6 to 5 volts. Oh, I got to do some math. I'm going to turn off the camera, do the math, and I'll come back. I don't think you need to see me struggle and smoke come out my ears. It has been hours, and I don't have a whole lot to show for it, but I'll show you what I've got. Since I last had the camera on, just to simplify things, I did 200 steps for forward, 200 steps for reverse, which worked out to each single-digit change from the potentiometer translated to a 12-digit change going to the 12-bit DAC. I have no idea if this is working. I turned the camera on before I loaded the sketch. I checked that it compiled, but that's it. I did a few things. I added a switch. What this will be is that if this gets set to off, it will tell the Arduino to set the DAC to 2.5 volts, which should put the controller into the neutral position. 2.5 volts is don't do anything. Actually, 2.4 to 2.6 is don't do anything. If it's within the range of the 200 values that I read from the pot, it sets, this is probably a little bit in the weeds, but I measured when the potentiometer is reading 265, that's max reverse, and that's a digital value of 0 volts full reverse. 465 is minimum reverse, so as slow reverse as possible, and that translates to a DAC value of 1965, which should be 2.36 volts, hopefully. Similarly for the forward with a different range, mon forward, let me change that to min forward. When the potentiometer value reads as 550, the DAC is going to be 2130, which should set 2.55. Oh, I got a problem with my math. That's too low. I need to get that to 2.6. Well, you know what? For now, it's fine for a proof of concept. It should be 2.56, and then 750 should go all the way up to 4.9 volts, 4095. I've got to tune this. I'm sorry, this is probably very boring, but this is my brain trying to work. From a logic perspective, if the value is higher than 750, assume max forward. If it's less than 265, assume max reverse. And if it falls off that if-then tree, put it to neutral, which is 2.5 volts. So the way that I should back up now, shouldn't I? The way that the DAC works is that 0 is 0 volts, 4095 is 5 volts, and each of the 4096 steps represents 1.2 millivolts. The value I'm sending to the DAC corresponds to a voltage output in steps of 1.5 millivolts. Now, because of the low resolution of reading from this pot, I'm actually 12 times that. So 12 times 1.5, what is that? 15 millivolts per step. So it's not going to be super graceful, but so it is. Okay. The very first thing I'm going to do before I write to the DAC is just look at the serial output and see if the values look sensible. If they do, then I'll send the value to the DAC, and then I'll monitor the output voltage. I've got, oh, it's so dark. I don't know why. I have to get better lighting. I'm sorry. All right, I think I got it lit up better. So I've got the voltage coming off of the DAC, and that's tied to ground, and this should tell me the voltage that I'm reading. None of this is particularly high resolution. Really, I need an oscilloscope. Better known as a silly scope. Anyways, let's try this. So it's going to boot up with the last value. I'm going to upload this sketch. Okay, so now at this point I should flip the switch off, and the DAC is now solid at 2084, which is 2.5 volts. So no matter what I do here, the DAC value stays the same because the switch is off, which puts the boat into neutral. So if I switch it on, now it's bouncing all around because there's no actual value on the potentiometer. Okay, so that is reverse, and that's going, there you go, max reverse. Slowing down my reverse to 2.3, 2300. I don't have to translate that into voltage. Now on forward, okay, so that's neutral, there's forward, and I'm going up, max forward. Holy shit, it's actually working. I'm sorry, that's probably too loud. I probably just had to mute that some. Okay, wait a second. I'm not writing to the DAC. Why is that 2.5 volts? Maybe that's just the stock is in between. That's not actually changing, is it? No, it's not changing because I'm not writing to the DAC yet. Okay, so I'm just going to leave the camera running for a second, and I'm going to look up what that DAC value was. DAC.setVoltage. Oh my god, if I get this working, I'm going to be so happy. DAC.set, was it SET capital voltage? DAC value? I don't know what the false means yet, but that's what Buddy has in his. DAC dot set voltage, integer, false, close. Okay, now let's try making sure it compiles. I have a problem. Why do I have a problem? DAC value was not declared in this scope. Oh, because I did an underscore instead of a capital. Oh, okay. Silly mistake. All right, now let's see. Does it render or compile? It compiled. Okay, now bring you in this setup. So I close the switch. Oh, I gotta go back to the serial monitor. Switch is on. Now it's floating because there's no actual resistance. Okay, reverse. The voltage is dropping. That's max reverse. 2.89. Okay, that's too high. So my voltages are off. 2.4, 2.2, 2.4. I don't want to go above 2.4. So I've got some figuring to do, but there goes the forward voltage. Max voltage 5.072, but then it drops forward. Okay, I get above a certain point and it drops to 0 instead of max forward. I'm hitting a dead zone. Forward, max forward. I'm in max forward, which is 5. Why do I hit that little 0 there for a little bit? Right now, what am I holding? The value is 4362 and the output voltage is 0.3. Okay, key thing is, I've got the foundation. It's vaguely working. There's bugs. I could sort them out. This has been a lot. My brain hurts. I think I'm going to stop for the night. That means nothing to you because for you, we have a little kitty interlude before we get back to work, huh? Hey, bud? Hey, bud? Yeah. So in real time, that finger snap was, I don't know, 3 or 4 weeks ago. I was not expecting to have that much of a delay. I thought I was going to be filming the next day. But then work became a lot, and it hasn't let up. And it's the first time I've taken a day off, well, partially, in almost a month. Anyway, none of that's your concern. Main thing, the reason I mention it is I haven't touched the Arduino code in a little bit, so I'm going to have to refresh myself. Before I do that, though, let me give you a little bit of an update what's happened in the last few weeks in real time, not for your time. What's happened since I did my finger snap? The original 48-volt battery that got turned into the two 12-volt batteries is going to be a 48-volt battery again. Now, for that I need a 16 SBMS. So I need the 48-volt battery working in order to be able to power the Kelly controller, so I can try to spin up the motor so that I can test the Helm controls. The other 6 batteries behind the scenes are going through a series of full charge, full discharge tests. I'm trying to check the health of the batteries. Anyways, point is, I can't use those for powering this. That's why I'm turning this back into a 48-volt battery. I'm going to use the old original JK BMS for now, because I still haven't decided what I'm going to do for BMSs long term. But part of the problem is I lost the cables for this. So, if you recall when I was building the 6 batteries, I took all of the spare wires off of the other leads because I didn't need them. So I have taken a bunch of those. I have started to put ends on them. I will put shrink tubing over the exposed metal of the rest. And then, not to get the wires mixed up, I will just plug them in manually one at a time. This is not ideal, but I also don't plan to keep this much longer. So if I really screw up and I blow this up, well, so be it. That's also the old version that needs to be booted with some batteries. But I don't need to do this anymore because I got a new toy. I'll show you the new toy in a bit. If you recall, for you a minute ago, for me weeks ago, I had a problem when I was running the throttle forward. There was a point where I would hit it and the voltage would drop out. So there's a bug in my software somewhere. Not a big deal, but using that stone, I couldn't really dial it in and then poke around with the code. So this is a super rough version of what the Helm throttle is going to be. So this will be mounted, I mean, obviously it's going to be mounted like that, and the throttle will go this way, but again, this is just rough. I've got the I've got a picture of it. I'll put a picture of it here. It is the little metal piece that has a spring and an acrylic ball on it that actually presses on the thingy that registers the voltage in the potentiometer. Nice thing about it is I can move it very carefully, and once I get it to the dead zone, I could just leave it, where I couldn't do that with a stone. And then I can, yeah. Anyways, we'll see more of that in a minute. The other thing I need to do to get that battery up and running is I need to build another one of my battery disconnect / T-class fuses. So I got another fuse. I have to still put this end on it. I've got another switch. And if you recall, the Kelly document was very clear on the fact that you must use a pre-charge resistor when connecting the power to this. So I picked up a couple extra resistors, and I will salvage my old wiring to get that connected. For now, it's just going to be a switch or a button or something. That whole lever thing, cover thing that I was talking about before is going to come later. That'll let me connect the controller, which then I can hopefully start powering off of the Arduino, and we can finally spin the motor. Now, I don't have active cooling on the motor yet. I've got some ideas. I'm currently planning to use a computer radiator, like you see with those gamer peoples they use. I don't know anything about that stuff, so I have to learn about it, and then I'll pick one, and that'll be what we use. I'm not going to make you watch me do all of the crimping and whatnot. I'm going to get a bunch of this stuff done that you've seen me do in previous videos, and I will bring you back when I'm ready to set up that battery, because if I'm going to screw up anywhere, that's going to be where, and if you're going to screw up, get it on the internet. Okay, so let me show you what I've got done so far. I repurposed the old Renogy switch that I was using for the DC-DC charger I did not get to use on the trip home to the pre-charge resistor. I noticed I was struggling really badly to solder, and I was talking to Andrew, and I just couldn't figure out. I had the temperature all the way up, well, not all the way down, but down to a reasonable number. It just wouldn't solder. And at one point he was like, I think your tip's toast. So I got a new tip. And he also got me to pick up a different kind of solder. Apparently it has resin core in the actual solder. Holy crap, did it make a difference. Soldering on these was way easier. So this is the same kind of a switch arrangement, except for this being added, that you've seen in all the other batteries. I've got what I need for the Anderson connectors, but for the sake of now, I'm not going to bother cutting that because those ends are really, really expensive. The parts you crimp on, and I figured I'll wait until I'm actually on the boat. This is good enough. I've got a disconnect switch. On the BMS itself, so similar deal, that's going to go straight to the Kelly controller, which goes through a smart shunt to the BMS, and then BMS to battery minus. That, I was going to put shrink tubing on the ends of all of them, but the shrink tubing was too fat, so I did every alternate. So there's no chances of it shorting, and it's in fairly tight. Now, because the wires go straight in, I don't really have any way of measuring the voltage when I plug these in, so I'm just going to have to be very careful when I do this. Before I assemble the battery though, what order should I do this in? I've been having an odd problem with the camera today. It randomly says viewfinder inactive and it stops recording. Anyways, so these tape marks full forward, full reverse, and then inside of here is the neutral area. So from there to that line is neutral. So if I go back to neutral quickly, I'm pretty sure this is just a math problem. So you can see it's about 2.59. I got to tune that a little bit, but anyways, it's in neutral. So you can see neutral there. As I go forward, watch the pot value increase. 5.4, 5.7, 5.11, and I see the DAC value increasing, and I see the voltage increasing. Exactly as I would expect. Oh no, I'm still in neutral. The DAC value hasn't increased. Yeah, because it's between 2.6 and 2.4 is neutral. So all through here, the voltage is 2.59 would still be considered neutral. Now I'm in reverse. Oh, okay, so I've got some math problems there as well. So this is the same problem I'm having on the other side. The DAC value, so 1656, 2.1 at 1716, 2.18, I'm at 1872, and at some point it's just going to suddenly jump. There it is. So that jumped to 2.5, and I'm still technically in neutral, so my math somewhere is messed up. 1836 at 2.29, 1884 at 2.3 volts, this is still good. 2040, I'm at 2.5, that's too high, because it still says I'm in reverse. 2016, I'm at 2.5. There he is. So 2028, nope, it jumped up again. 2028, there we go. So you can see what's happening there. This number isn't right. Similarly, if I come through to forward, it's really not stable. I'm not entirely sure I'm a fan of this anymore. It seems like how you press it changes the value quite a bit. Maybe that's something that could be sorted out when I have less of a janky rig, but anyways, here we go. Yeah, see how the voltage is all over the place? 590, 490, 5... I think I might be going to a rotary pot. It's not that I'm worried about corrosion, it's that it seems to be too sensitive. Maybe I'll talk to Spectra and see if they have any advice. But tightening it up seems to have stabilized it. I'm in forward now. My voltage is 2.6, that's good. So 555 is 2.7, 563 is 2.84, 2.87, 2.9, 3 volts. I'm just watching the voltage now. Waiting for the voltage to fall off, and then I'll look at the pot values. 4.9. Once I hit 5, I think it's like an overflow and it suddenly drops down to 0. 5 volts. That should be full speed. But I'm not all the way through. 714. There it is. 714 and the voltage dropped to 0. 714, it overflows. Now the DAC is 4098. So if I back up just a touch to get to 713, so 712, 4074 is okay. It could be that I'm sending a value to here that's a bit off. Well, 714, so one step up should cause it to go to 0. And sure enough, that's what happened. 714 and it's 0. Okay, so this is what I need to figure out. I need to figure out what's wrong with my software and why this is happening. But you can see why I wanted to make that handle. I can really fine tune that. No way in heck I could have done that with a stone. So I don't know how to make math and experimenting interesting on camera. So I'm going to turn it off now, and I'll bring you back when I have an answer. Hello to the day the next. So after I turned off the camera yesterday, I took the source code and I wrote a little Perl script. I was able to take the sketch, the program that I wrote for the Arduino, and move it into Perl, obviously without talking to the real hardware, just so that I could test to see what was happening with the values that would have been coming from here, sitting more comfortable at my couch, if I'm completely honest, and it meant I didn't have to do this. So when I did that, I realized my mistake was that I had hard set the steps. So for each digit that the potentiometer value changed, I was changing the DAC value by 12. That was too high. When I was in reverse, and I was slowing the reverse, so I was bringing the throttle forward, it would allow it to go into the voltages that are supposed to be neutral. Conversely, when I was going all the way forward on the throttle as if I was going to full speed, once I crossed over 4095, whatever the number was, I tried to start sending values to the DAC that were too high. So it's a 12-bit DAC, which is 4096 steps. When I tried to send the values above that, it basically flipped around and set the volume back to 0. There's a fair bit of math. I mean, it's not super complicated by any means. I don't know if I mentioned it earlier, but I've put the source code up on GitHub. It's all going to be released under open source. I'll put links in the description for anybody who wants to actually see the code. In brief, where initially I hard set all of the values, I've now set a set of static variables at the top where I can say things like, what's the neutral point? When does the neutral start? When does the neutral stop? It's kind of like a calibration. So I could sit here with any particular throttle, bring it to full reverse, see what the digit is, bring it to the start of neutral, see what the digit is, the start of forward and full throttle, take those numbers, throw them in, and it does all the math for me. It was actually doing that I realized when I did that math, it was showing me like 9.875 DAC steps per pot step. So now that is being auto-calculated. I know it worked on the Perl script. I have now ported it over to the sketch, but I have not loaded the sketch onto the Arduino yet. So that's where we are now. But in theory, this should be much more stable output. So this is the GitHub page for it. I haven't actually started using proper branches or whatnot, so anybody who uses Git, please don't completely throttle me. I know that I'm not doing it right yet. Anyways, so if I go into pull requests, and for anyone who doesn't know programming, I'm sorry, I'll try not to belabor this too much. I know not many people here are for programming. But I mean, it's all about me learning, and I'm learning this. There it is. Helm Control. So I loaded this into the IDE on my other laptop just to make sure it compiled properly, and it did. Oops, jumped too many windows. So now I'm going to do a validate. Yeah, it's not connected, that's fine, but it didn't throw an error message. So let's connect, and let's push it. Okay, you see the output has changed, and one of the things I should have now is showing the percentage throttle as well. All right, so we're in neutral. Let's start going into reverse. That is not right. Forward 0%. Okay, I screwed something up, but that's okay. Reverse 100%. Okay, yeah, I've made... Switches on, DAC is 621. So it is sending the DAC values properly. I should go into neutral here in a second. Yep, now I'm into neutral. Notice to the millivolt, this is the theoretical millivolt out of here. One of the things I'll do later is have a part of the calibration at the top where you can set the voltage offset from what the DAC thinks it should be sending and what you're actually reading with a multimeter. So the idea behind having the parameters at the front is that I could build 2 or 3 of these throttles, have them in storage, but when I build them, I can actually go through and test what the various values are at different throttle positions, put that in, and then also check the output voltage and see how much it's off by, so that I can have these things with their own Arduinos built into the throttle, or ESP32s, whatever I end up using, that are pre-calibrated for that device. So that if I have to replace one in a hurry, it's literally just unplug it, take the next one, slap it in and plug it in, and it's back up in business. All the logic will be in the throttle. Okay, so it thinks it's going to be putting out 2010 millivolts, but I already pre-calibrated this to 2010, knowing that that was going to get me close to 2.5. So let's go all the way back to full reverse. I know the wording is wrong right now. So there's a reverse 100%, 0.0 volts. So now as I go up, and it thinks that I'm getting 0 millivolts, so that much is accurate. There we go. So I know I'm doing steps of 9. So the DAC is expecting 9 millivolts, and I've got 0.011. So pretty close. That's not too far off. So now you can see, just pick a random point. It thinks it should be 405 millivolts. It's 506 millivolts. So that's actually already off by a fair bit. So I need to figure out how to calculate these offsets. I should go into neutral here in a moment, and you should see this immediately jump to 2.5. Where's it going to neutral? So I'm at 2.2. Bam, there it is. So if you see here, there, 2.2 is the highest it'll go for reverse. So that's minimum reverse is going to be 2.2 volts. As soon as I fall into the neutral range, it goes straight to 2.5, and it stays there. It'll stay there as I come forward, and then it'll suddenly jump to something over 2.6. Still in neutral. There we go. And then it jumps to 2.65. So that'll be just the lightest throttle forward. Now, if you remember before, there was a point, oops, where this would suddenly go closer to 5 volt and then drop down to 0 and then jump back up again. That should be fixed now. 3.5. And I've got this polling every 0.5 of a second. In reality, I'll have it poll more often. I just wanted to slow the roll of the output so I could actually see things better. 4 volts. I think this was roughly about where it jumped before. But I'm getting a smoother gradient, so I'm pretty confident this is fixed. 4.5, 4.6, 4.9, and then 5 volt. So what I did is I hit forward 100%. So it goes 4.8 and then suddenly jumps. I don't want that jump there. I want it to be a smooth transition right up to the max, and the same thing down. But that's a little bit of fine, I bumped my microphone. That's a little bit of fine tuning, and I don't need to worry about that for connecting the motor for the first time. So I'm calling this fixed. I need to fix the textual output. Oh, I don't know if I included this because the camera messed up on me. 1 second. Editing Madi will cut this out if I did show you this earlier. So if you're seeing this, it's when the camera cut out. So I don't know if I mentioned, I think I mentioned, one of the goals I really want with this Helm is I wanted to keep the 1980s aesthetic. I want this to be something that if you stepped onto the boat in 1981, it would look high-tech, but it wouldn't be out of place. So, instead of using like a nice OLED display, I wanted to use something that would be more time-appropriate. So this is a standard 2-row, however many character LCD display. You would have seen these definitely back in the day. But it's red, which should be easier on the eyes at night. So one thing I'm going to be very careful about is not messing up night vision. This uses the SPI. I have no idea how to use this, but it's with this in mind that I wanted to show the throttle position on the screen so I can actually see where my throttle is. There's 2 lines. One's going to be the throttle position. The other one's going to be very basic battery information, like current state of charge, estimated runtime, etc. But in a very 1980s feel. But we'll come back to this later. I did check that this had a library for the Arduino, more specifically for the AVR, and it does. And I'm going to turn off the camera until I figure out what's wrong with here, and then I'll bring you back. With the help of Andrew, I've got it figured out. I had to say that because I didn't know what I was doing. I don't know what I'm doing, but that's okay, I'm learning. Briefly, before I get into the details, it fundamentally came down to typing. So typing means like, does this variable contain a string, an integer, a floating point number, etc. One of the upsides or downsides to Perl, for those who program, is that Perl doesn't worry about that kind of stuff. You just create a variable and you throw whatever you want into it, and it figures it out for you. C doesn't. So the voltage, the predicted voltage was off because you have 0 millivolts to 5,000 millivolts. You have in actual voltage range coming out of the DAC. But you have 4,096 distinct steps, 0 through 4095. So each step was like 1 point some small number of millivolts. It was rounded just to 1. So that's why as I got higher up, it got further drifting apart because it was taking whatever the value I was sending to the DAC times 1, rather than times 1 point some number to give me the actual number. So that's sorted. And the percentage on the throttle was a similar problem. So I have 200 steps, so I was doing 100 divided by 200, which should have been 0.5, but it was coming out as 0. So that's why that was off. Anyways, let's go through the code really quickly for those who are interested, and also it's a good refresher for me because I'm learning all of this new. So you can see right now it's in the neutral position. So we've got a bunch of data coming out the bottom, but we're going to ignore that for now. So one of the things Andrew showed me was about math and int types. This is going to be ported to an STM32, which this is an 8-bit system, that's a 32-bit system, so this is a way to make sure that things don't break when I port it later. Alrighty. So I set up the variables at the front, which are all the, what's the pot reading at the start of forward, the end of forward, the start of reverse, the end of reverse, etc. And then I do my maths here, and then I come into my loop. I read the OPU switch. This, if you remember earlier, so if I put the throttle position to say forward, and for whatever reason, I want to immediately ignore this and go back to neutral, I flip that switch, and it's not working. Okay, so it's reading it, it's just not, oh, it is working. Right, I forgot I changed the code. Right, okay, so if you see the switch position here, what I'm not doing is, oh yeah, the DAC position went to 2010. Flip it back on, and it goes back to where the throttle is now, which is 2778. Okay, well, actually the sensor is 622, which translates to 2778, which translates to 3.4 volts. And that's vaguely what I've got here, which puts it into forward 30%. What I didn't do right is it still shows the forward position. It's just, whatever, that's just a display bug. So here's where I set up some statics, blah, blah, blah. I do my math. I already showed you all of this. I don't really know. They say that if you can't explain something simply, you don't really understand it. And I'm having a hard time explaining this, which means I still don't properly understand it. But it's working, and the code's up there, and you can look at it. This will make more sense to me as I use it more and more down the road. The point is, it's working now. So why don't I just show you that? So that's what really matters. It's working well enough that I'm actually ready now to feed this into the Kelly controller. So start off at neutral position. So you see that the sensor position is 492, but the DAC is 2010, which is 2.5 volts. I stay in my neutral until I come past that piece of tape. I don't know if you can see that over my arm. So I'm still in neutral, and that should be right at the beginning of forward throttle. Yep, 2%, 4. You can see the voltage going up, climbing, climbing, climbing. I think I need to back this pin off a little bit. That's okay. And then I hit full throttle. Anything past here, it stays full throttle. Now, coming back to neutral, and now I'm in. Okay, that was a bug. I don't know if you saw that for a brief moment. It was showing, it's spooling out too much. I need to see what that value was. Let me stop the output. Now, is that because I bumped this? So one of the things I'm really worried about, and one of the things I still need to add, is that if there's suddenly a major change in the throttle position, don't just immediately send that data to the controller, because that's going to be really hard on the motor. I need to say that if there's more than an X change in Y reading, spread that out over so many cycles to give the motor time to spin down and switch directions. If this was because I bumped it, that's not going to happen when this is built, because this will be stuck down and nothing will be able to touch that. So let's turn this back on and see if I can reproduce that problem. So right now, if I tried to send that to the controller and that happened, it would suddenly make the motor go, and that might be hard on it. Okay, so there's the reverse, and that's proper. Reverse 95, reverse 100. And again, if I flip the switch, immediately goes to 2.5 volts. That'll become like a push button switch or something on the Helm later. So, not being close to that pad, if I move this back and forth, I should not see this suddenly jump. And again, it's only pulling twice a second, so it's not pulling very fast yet. Neutral. Okay, I think it's just because I bumped that pad. Yeah, so if I put it into neutral and I bump the pad, yeah, there I get 100. Okay, so it was just me bumping that pad, which is just because this is a hacky setup. I have no idea how I'm going to put all of that together in a way that isn't terribly boring. So, I mean, by the time you're watching this, I've already figured it out. But me right now, sitting here thinking about this, I have no idea how to edit this into a video. I think I'm going to call this an episode because getting that working was a hell of a first step. I mean, maybe not for somebody who does this normally, but for me it was a really big deal. And I am now happy with this. The next episode, I'm going to assemble the battery, power up the Kelly controller, and figure out how to program it. I'm pretty sure I can use my serial adapter to USB adapter to be able to load the software up and start configuring this. I don't expect it's going to be a big deal, but as I sit here right now, I have no clue how to do that. But it's okay. I'll figure it out. That's the theme of the channel, isn't it? So once I've got that programmed, then I need to figure out where to send the voltage pins here. Once I've got the voltage pins going into here, which I'll probably just like jam something in because that's all I need to do for now. We'll get this set up to this. Well, basically the next episode, I want to spin the motor. It's been far too long that this thing's been sitting on my table and not doing anything. Let's fix that. Also in the next episode, one of my patrons went way above and beyond and sent this to me as a Christmas present. It is a proper bench power supply, a Raiden Romeo Delta 6024. It does 60 volts, meaning I can use it to charge the 48 volt batteries, which is good because I'm setting up this 48 volt battery up here out of, well, the original one, while the charger and everything is downstairs. So I wouldn't have had a way to charge this, which is very useful timing. Obviously it won't charge as quickly, but it'll charge, and that's great. So, Steve G, you know you are. Thank you very much. It's crazy. I have not turned it on yet because I actually want to, I've never used a real bench power supply before, so I want to get that on camera as I learn how to use it. So that's going to be used to charge this thing up. The batteries, this thing, you can't see what I'm pointing at. Use the bench power supply to charge that up, assuming I don't blow up the BMS while I'm getting it set up. We'll get the motor powered up and configured, and we'll connect the motor, and we'll actually spin it. I'm the Digital Mermaid. Things are getting really nerdy, and I'm really excited. That programming this, as somebody who doesn't do this kind of stuff and used to think that this was black magic, this is making me very, 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 very happy. Yeah, if you like this, please, usual YouTube doobly-doos, like and subscribe and all that stuff, because it actually really does make a big difference. Thank you, and I'll see you next week. Forward, neutral, reverse. If this isn't the sketchiest thing you have ever seen, but it should allow me to get more consistent readings from this. Well, more specifically from the pot. It comes loose after a few turns, so I'm gonna have to keep tightening it, but that's okay. This is gonna make it a little bit easier.